So this is my first talk, like at a conference ever. Before this, I think it was like 20 people in a room. Yeah, thank you. So, yeah. And we're gonna do some live coding. So Leroy Jenkins. About me, I am a solutions engineer at a company called NodeSource. We do like node consulting and stuff like that. One of my roles there is I maintain the Docker images for NodeSource, and we offer version pinning for Node, so that if you're in the Docker community and you're rolling out Docker images that are Node-based, you can do version tracking. So you can track against like major or minor point releases. So you can choose which updates are automatically going to make it into your base images for your Docker images. Yeah, and of that like work I've been doing, it's resulted in a bunch of like research and development in my own personal time. Of that has been trying to wrangle cats with a lot of like these big, large software projects I've been working on, which involve a lot of moving parts. Naturally local development with like service-heavy applications, and that's what on this talk. So rapidly iterating on microservices using Docker and Node.js, all of the buzzwords. So some exciting trends, which have led up to the problem that we're currently experiencing with local development. And I'm sure as we start describing these, like everybody in the audience is going to be able to relate to this. But some of the cool things that are happening in our industry that I'm really excited about is we started like seeing a separation of concern at service boundaries as opposed to like inside of your code base. So since I started like hacking in high school, a lot of the things that we've been moving more and more towards has been like out of thread-based work queues and more towards like service-based work queues. So your application no longer has a bunch of threads inside of it working through like disjoint, unrelated tasks, like Twitter, posting to users' Facebook accounts, registration, emails, SMS, things like that. Things that can be done asynchronously. They're no longer being done inside of a monolith. They're being done in microservices outside of that application. And that comes with a lot of really cool things. One of which is you can choose which services those things like rely on. So whether that be like Redis or Postgres, you're no longer stuck with a big Teradata SQL server that everybody gets access to, and you just have to deal with it. You can bring these things into your application, and developers are getting a big say in the services that they're able to use. And what this has caused is like a proliferation of some really cool specialized services. We've been seeing a lot of graph databases showing up, key value stores, et cetera, and all of these are making it into our code bases. So like a simple application nowadays doesn't necessarily have like one SQL database that it talks to. It may be Redis, Elasticsearch, Postgres, and Nginx all required just to do like a simple task, and all of this deployed in the cloud for something simple like a badging service. And trying to just wrangle those cats around those services, like that's a large task locally. And I'm sure like all of us, we have projects like this at work or at home where we have more than one service, and we're trying to spin these up locally and develop against them, and trying to get this like installed and like a day of yak shaving just to get Nginx set up locally on my laptop so I can work on this project. That's ridiculous. We need a better solution. So that's what today is about, is addressing that pain and finding an awesome workflow that actually empowers us to like get that stuff out of the way so we can go back to what really matters, which is writing code. So what we're gonna do is we're gonna introduce some high-level concepts around Docker and Docker Compose. Docker is going to allow us to define our services like our custom-built services in Node.js, put those inside of a Docker container, and then rely on third-party Docker containers like Postgres and Nginx. So as opposed to having to set these up and develop them locally, we're just going to pull them down in like 2-line addition to our Docker Compose file. We're going to have that running locally, and we can query against it. And then with iNotify is this cool little hack that we're going to use for local development, which allows our Node microservice to automatically restart itself without having to restart the entire infrastructure locally. So without this Docker Compose, every time you like made a small change to your Node file, you'd have to restart the entire Docker Compose architecture that it's managing, which could take up to like 30 seconds, and that's kind of anti-Node. So getting iNotify in there to watch your code base, I'll introduce that in a minute. But yeah, so let's jump into some code. So we're looking at a simple Express app here. I'm not gonna write it out in real time. But we have a simple express app here, which basically just listens on port 3000 and responds with the simple string. In this case, it's hello world. And what we're going to do is we're going to take this simple Node app, which is representative of any Node app that you're working with at home. We're going to create a simple Docker file. We're not going to dive too deep into what these actually are. We have some, like if you go to the node source websites or Blankenship.io, I'll put some links up in a minute. They have some awesome tutorials on how to do this and take your own code base and put it into Docker so this works. And we'll talk about that in a moment. But this is just a simple Docker file that takes that simple Express app and puts it inside of a Docker container so that we can hook it up to other Docker containers and do cool stuff. So we're just going to, inside of here, run docker build. Tag it with test. And our code is now inside of a Docker container. And then I can do something like docker run, bind it to the TTY test, and you can see it's listening on port 3000 inside of the Docker container. Can't actually get to it from the web browser without exposing the port, but that is beyond the point. Okay, cool. So starting from that, we have that basic Docker file that we've just taken our Node application, we've put it inside of Docker, and now we're going to start doing cool things with it. First and foremost, we're going to need a Docker compose file, and the Docker compose file basically defines all of your service dependencies. So all of the things that your application like leans on to run, but you're not writing the code for yourself, whether it be like Nginx or RabbitMQ, like we're going to introduce in this talk, or maybe it's something like another team in your organization is developing and maintaining themselves. You can define them as Docker files or from the Docker imagery or registry, pull them in, and the building block of that is going to be the Docker compose file. So we're basically doing the same thing here. We can run docker compose up, and you can see it's listening on port 3000. I go over here, I refresh, and you can see hello world, which was already there. So I guess we'll kill it and refresh to prove that it's not smoke and mirrors. Okay, it's not there, so yes. All right, so now we're deciding that in front of our application, which isn't just a hello world application, it's whatever you're doing at home, you decided you wanted SSL and you wanted to gzip things for compression, like basically when you're getting ready to take something and like present it to the world, the things that you normally want to do, and the things you don't want to do in Node because data crunching is hard. So gzip, we're going to do some caching at the Nginx layer, and we're just going to create this simple Nginx file. It's literally just like pulled straight off of Stack Overflow and dumped in here. We're going to take this, we're going to drop it into a folder Nginx locally, local in our project directory. And we're going to then open up our Docker compose file. And as opposed to having to actually install Docker or like Nginx locally and spend however long shaving and trying to configure this, and then have a shared space where every application that you need to or that relies on Nginx that you're working with locally, whether it be 2 or 3 or 4 for your company, all sharing that same Nginx instance and having a bunch of configuration files that you're swapping in and out of that confd folder. You just bind mount it into its own Nginx instance with these 6 lines. You run docker compose up. And you can see over here we're on port 8080. We're going to go to port 127. 3000. We're still hitting the original producer app. Come over here, we refresh, and we're hitting Nginx. So instead of having to set up Nginx locally, we have Docker do all the heavy work for us, and we can go back to focusing on our application. All right. So the next thing we're going to do is we're going to take our logging service, and we're going to break logging out of the application itself using RabbitMQ. So all of the RabbitMQ magic that's going on with connecting and all that is done inside of log in this nice little module that we've created. All it does is, in addition to app.get, where it was previously doing response.send, we're now putting in a log request in there, or calling a log function, passing in our response, which was hello world, or exiting out of the function. So same thing, but this time we're also emitting an event on RabbitMQ. And then we're going to create a consumer. So we're adding another one of our microservices in here, and this just accepts it, or listens for the log event, accepts the message, and then does a console.log. This would be something that you would typically hook up to your Postgres database or something along those lines, some off like shore logging solution that you guys use. But in this case, we're just outputting it to console.log. All right, and then for RabbitMQ, all you have to do is you have to drop RabbitMQ with image RabbitMQ into your Docker Compose file, and that's literally it. It's 2 lines, and you have RabbitMQ up and running for your application. And then these lines here, we can link our producer and consumer to our RabbitMQ instance, so that if inside that container they were to if you were to type ping RabbitMQ, the DNS would resolve to the container locally that's running orchestrated by Docker Compose, like through magic. Oh, Docker. All right, so we started them up, and you can see, in addition to Nginx, we now have RabbitMQ running. Our producer started up, connected to RabbitMQ, and our consumer started up and connected into RabbitMQ. We refresh over here, and you can see our consumer is emitting hello world. And then we can go over to our Nginx instance, and when we refresh, you can see it does that cache the first time, and then from that point forward, Nginx is caching. So we have this nice caching layer on top, in addition to the logging event that's happening on the back end, right? All right, and then from that point forward, we realize that we've run into this kind of problem where we decided we want to put all of our services inside of a container, and this is one of the first things that you'll run into while going off on this tangent of, or this going down this rabbit hole of trying to tame the services on your system. You're going to run into the problem of having to restart and rerun Docker Compose over and over and over again, and you're going to get kind of sick of waiting 30 to 45 seconds for some complex services to start up at boot. So what we can do here is, as opposed to just allowing our Docker file to build and bake all of the files into our Docker image, we start off of, roll back, as opposed to starting off with a Docker image that has all of our source files baked into it. We bind mount the volume with our source directory into the Docker container. So the Docker container is sharing the volume with the host system. So the directory is inside and outside the container, right? We mount it into the container read-only so that the application itself can't modify that volume, which is really great for production, not necessarily necessary for development. But then we write a very simple script. Like you might want to use supervisor for this or nodemon. This is a simple bash script, and what it does is it uses inotify wait, which is part of the inotify toolchain. And it just basically, it watches a directory or a file, and if the contents of it changes, it runs a command. And in this case, basically what we're doing is we're blocking this infinite for loop while inotify waits for something to change, and then it'll return. We'll kill the previously started version of our application and restart it. So what this allows us to do is then go into our Docker file. We'll comment out our original command, which was just start our application. And instead, we'll install the inotify toolchain. And then we'll call our watch script, and we'll pass in the application that we wanted to start. In this case, Node app.js, and that was passed into exec. So this is going to restart our application. Like I said, like you can use supervisor or whatever you find useful to do this for your normal development. Just bake it into your Docker image. The biggest thing to take away from this is if you guys use Docker in production today, don't ship this Docker file to production. You don't want this tooling to be in production and your production servers to be restarting every time something changes on the file system. That's probably bad. But we're going to go ahead and we're going to run Docker Compose up here. We're going to kill all the Docker containers that are left running in the other screen. We're going to go ahead and bring it up. All right. So over here we have hello world, and then we have our Nginx, which is still caching. And if I was to go in here and I was going to change world to our service restarts, hello Empire node, and then we should theoretically see, yep, Nginx is still caching. So in this case, we just live reloaded our application. It's still talking to the same RabbitMQ instance that's running locally, and all of these are isolated. And this isolation is huge. What this means is if you're running, like, for example, Elasticsearch, and your project requires 2 different versions of Elasticsearch, say, like, you're working on 2 projects in your company, one requires this version and this one requires this version, and they both require different versions of the Java runtime, and they can't both be installed on the same system at the same time. This allows you to do that by putting them inside of Docker containers and spinning them up side by side. So you can actually have both of these living happily side by side on your on your development machine without having to use like virtual machines or anything along those lines. Yeah. All right. So thus concludes live coding. You're going. All right. So if you guys decide to like do this at home, which I highly recommend, and like give feedback into this like workflow, like this is something that's very rudimentary, very like early stages. Like this can be optimized a lot in a lot of places. But when you guys get home and you start playing around with this, like one of the biggest like awakening moments you'll have is when you go to take your applications and put them inside of Docker containers. You'll notice how poorly documented your installation process is. Like this is always the first like hurdle to get over, and how interdependent all of your services are. If you run make build on your application, and your application building also touches your Redis database and your Redis instance and your MySQL database and populates all the schemas and everything else, it's not going to work very well inside of Docker. And that's because you have all of these interdependencies that really shouldn't be there, and that's technical debt that you're just shaving at this point, right? So you're going to get frustrated with these. And then the next like couple of points are just for like microservices in general, and just making like things easy to scale. One of the awesome things that you'll see. Does this sit? Yeah. We're gonna go ahead and bring this one back up real quick. One of the things you'll see is the ability of like elastically scaling things once you get them inside of Docker containers. As long as you like or subscribe to this model of development. In this case, I just spun up an additional 10 consumers of the RabbitMQ queue that we are publishing our logs to. And you can see if we go over to the Nginx, nothing. This is Nginx. Yep. Nothing happens. But if we come over here, our consumers all handle this asynchronously, right? So each one grabs it, its individual log, handles it, processes it offline, right? So this, like, with this like workflow, we end up like with a byproduct of easy, scalable like services. And one of the reasons for that is when you're using this workflow, you're going to find that you're constantly restarting your services, you're constantly replacing your services, interchanging them. And that isn't like lending itself very well to the classic model of development, and that your service usually starts up in its environment as fresh. So what this means is don't assume that services are always there. So your services that you depend on, whether they be your own microservices or something, they may go down, and you don't want to have cascading failures, right? So if you have 4 or 5 of your own little microservices and they're working together and one of them goes down, that shouldn't bring down the entire system. And then you shouldn't assume that you're the only service like of your type running. So if every time your service starts up, it tries to do something special to the database that can only be done once, or it has to be done like in a specific set like order, like that's going to break when you start scaling, right? And you're going to run into that really early in this workflow when you start like using the Docker compose scale command. Things are going to start breaking and you're not going to know why. And it's usually because you're not working in transactions, or you're making an assumption that nothing else is going to be touching the database when you are. You can't make that assumption. And then the other one is don't assume that this is the first time that you started, which is kind of related to the last one. If every time when you start your application, you're doing like an INIT process on your database and like trying to create a bunch of tables and things like that, and you assume that those tables aren't there, your process is going to start failing every time you start it up. You shouldn't be doing that. That's just a general like production no-no, right? All right, and where to go from here? If you decide that you do want to pursue this, Blankenship.io has a bunch of blog posts on how to take your applications and get them into a Docker file, from starting with a Node project, generic Node project, get it into a Docker image. And then from there, taking your Docker image and tying it together in Docker Compose. It's really nice, detailed step-by-steps. Another one is Martin Fowler. If you are interested in like the microservice like architecture, when you want to start playing around with it, he has awesome reading material on his blog post. Definitely a thought leader in the space. You should check that out. The NodeSource blog, we're going to be updating with a bunch of stuff as I iterate on this, and it's all ending up in these blog posts that are going out on the NodeSource website. And then Finally, the Docker Node repository, where we offer version pinning for your Node images. Check those out. Give us feedback. Let us know what you think. And yeah, and finally, if you want to use microservices in production, definitely recommend building microservices. This book is fantastic. It goes through everything from like security considerations to monitoring to like all the yaks that you'll end up having to shave. They're pre-shaven in here. So like grab this book. And yeah, thank you.
Hello. Oh my goodness.
Yeah. Well, I was going to hide this back there, but okay.
Oh, yeah.
Yes.
Okay. Tell me, if you were a hip hop artist, what would your stage name be?
I was very prepared for that. Something very boring.
Okay,
Something
perfect.
very boring.
Also, that was a great talk. Congratulations on your first talk.
Thanks.
Weirdest thing you've ever eaten?
Weirdest thing I've ever eaten. Some really weird squid dish that I had in San Diego, or near San Diego, Del Mar Heights.
You
I
know
have no
what-
idea what it was called.
Yeah, you
it
know
was
what
good.
they say about San Diego, those weird dishes. What's your favorite band?
Green Day.
Oh, okay,
Green Day, yeah.
very interesting. Favorite solo artist? Also Green Day.
Yeah, sure.
Favorite lyric?
Favorite lyric. Probably Good Charlotte. Like high school feels more to me like a jail cell. Yeah, that thing. Yeah.
That's why you dropped out.
Yeah,
Perfect.
That's not really why I dropped out, but I like postmortem, yes.
Okay.
I can connect with that.
Thank you so much. That was awesome.
Thank you. Thank you, guys.